Hi guys, Mr. Mackey here. Now yesterday I was showing you loads of different types of sequences and how you can find the next terms in several of them. And I set you this challenging puzzle where all I wanted you to do was find the next 3 terms of this sequence and why. Now if you didn't get it, that's totally fair, because only 5 people have ever been able to solve this puzzle. And today I am going to show you how to solve it. Now what you've got to do is you've got to imagine it as if we're counting from 1 to 10. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. Now, ask yourself this. How many letters does the word 1 have? Are you starting to figure it out? If not, how many letters does the word 2 have? That's right. They're the number of letters that the number it corresponds to have. So 3 letters in 1, 3 letters in 2, 5 letters in 3. So that means that the next 3 are going to be the number of letters in the words 11, 12 and 13, which are 6, 6 and 8. If you got that, absolutely fantastic. If not, it is a challenging puzzle. Now, for the next 2 days, we're going to be focusing on one specific type of sequence, and they're known as a linear sequence. Now on the board is an example of a linear sequence. Can you identify what could make this sequence linear? You figured it out? Have you noticed that they are adding the same number every time? There's a difference between 4 here, 4 there, 4 there, 4 there, and 4 there. So this sequence is increasing by 4 every time. And that's what makes a sequence linear. If a sequence is increasing by the same number every time it happens. Now this could help us find the next term of this sequence. This could help us find the next 3 terms, as a matter of fact. So if we know it's going up by 4, all we need to do is add 4 again. That will get us 29. Add 4 again, get us 33. Add 4 again will get us 37, and we can carry on. And that's a great example of how linear sequences work, because if we're adding 4 every time, that's what makes it linear. This is another example of a linear sequence. Why? Because it may not be increasing by the same number, but it's decreasing by the same number every time, which is 3. So we're decreasing by the same number. So it's not just increasing, it's decreasing. And because of that, we can find the next 3 terms. 7 take away 3 gets us 4. Take away 3 again gets us 1. Take away 3 again gets us to -2. So you see, we can even use negative numbers in sequences. As long as they meet the rule that we have, which is decreasing by 3, we can use negative numbers. We could use millions, as long as they meet the rule. Now this is an example of what the nth term of a linear sequence is. Now, the nth term is basically the rule of the sequence. So when we wrote the sequences going up by 3 every time, this is another way of putting it. So what does this sequence mean? How can we create a sequence from this? Well, I'm going to show you how to create the first 5 terms of this sequence, 3n plus 2. So for term number 1, we put 3 and we replace that n with the number 1 and we add 2 to the result. So what's 3 times 1? 3. Add 2 gets us 5. Term number 2. We replace that n with a 2 because it's the second term, plus 2. 3 times 2 is 6. Add 2 gets us 8. Third term. 3 times 3. Add 2. 3 times 3 is 9. Add 2 gets us 11. Now, remember when I said it was a linear sequence? That means that these terms will be increasing by the same number. So what is the difference between 5 and 8? Any ideas? 3. Difference between 8 and 11 is also 3. So that means to find the 4th term, you just need to add 3 again. And then to find the 5th term, add 3 again. Once you've started getting this sequence generated and you know the difference between the terms, you can find however many terms you want. It's cool, isn't it, once you know how? Now let's try it with this sequence, 5n minus 2, and I want to find the first 5 terms and the 100th term. We'll get back to that one in a minute. So, we do 5 times 1, because it's the first term, minus 2. 5 times 1 is 5, minus 2 is 3. The second term, so we put a 2 in there, take away 2. 5 times 2 is 10, take away 2 gets us 8. Because it's the third term, we put a 3 in there, take away 2. 5 times 3 is 15, take away 2 gets us 13. They're all going up by 5s, aren't they? So as you can see, 3 to 8 is a plus 5, 8 to 15, 8 to 13, sorry, plus 5. To get to there, we plus 5 again, so that will get us 18. And then to get from 4 to 5, we add 5 again, so that will get us 23. Because now we know the sequence is going up by 5s every time, we can just add them on every time. Now there's 2 ways to find the 100th term of the sequence. The long way, which is we just keep on adding 5, so it becomes 28, 33, 38, 43, 48, 53, 50. I got bored even saying it. That will take way longer than a video, and I think you'll be bored and probably finish your GCSEs by the time I reach the 100th term. But there's a quicker way. So, if we're looking for the 100th term, all you've got to do is replace that n with 100. Like so. So what's 5 times 100? 500. What's 500 minus 2? 498. And that is all you have to do to find terms in a sequence. Let's do one more before the challenge. So I have the sequence 80 minus 4n, and I want to find the first 5 terms and the 52nd term of this sequence. So let's find the first 5 terms firstly. So we do 80 minus 4 times by 1 because it's the first term. So what's 8? So so we have 80. Take away 4 times 1. So it's 80, just take away 4. That will get us 76. Next one, we have 80. Take away 4, but we're timesing that negative 4 by 2. So negative 4 times 2 is negative 8. So it's 80, take away 8. That becomes 72. Next one, 80 take away 4 times 3. We're times that negative 4 by 3. So it becomes 80 minus 12. And that becomes 68. Have you noticed by now that the sequence is decreasing by 4 every time? So we're decreasing by 4 to get to here, which gets us 64. Decrease by 4 again to get to 60. And that's how we find the first 5 terms, because we know they're decreasing by the same amount because it's linear. So how do we find the 52nd term? Well, it's very similar to what we did in the previous question. We do 80 minus 4, but we're timesing that 4 by 52. You might need a calculator for this one, but negative 4 times 52 is actually negative 208. So it's 80 minus 208. Does anyone know what that would get you? That would get you negative 128. If you got that, fantastic work. And we can now use this to find any terms. As long as we have the rule, we can find any term we want in a sequence. So now we can find terms from sequences. What if I set you this problem? I have the sequence 6n plus 5, but only one of these terms belongs in this sequence. My challenge for you today is to figure out which term is part of this sequence. I've not taught you the methods to do this, so you're going to have to figure it out yourselves. See how you do. I'm looking forward to seeing what you did for this. Good luck. Have a good evening, and I cannot wait for tomorrow's lesson where we're going to go into a bit more depth on linear sequences. Good luck. Take care.